Okay, so let's say that we're going to toss a coin 4 times. Here's the first toss, the second toss, the third toss, and the fourth toss. And we make a tree diagram for that because our question here is, what's the probability of it not being the same all 4 times? Not being the same. Well, when we write it as our tree diagram, it's pretty easy. We could first, we'll start again with, we could get a head or a tail. We could then get another head and another tail, another head and another tail. When we toss the third time, we could get a head and a tail. And if you write them in the same structured way, where you keep the same format every time, if I'm starting to write heads first, I continue to write heads first. It makes it really easy to follow your tree diagram later. So heads, tails, heads, tails, heads, tails, heads, tails, all the way through, every single time that we write it. Because now it's really easy for us to see, okay, on which of our lines is it exactly the same number of the same side? Well, only here on this side is every single coin a head. We have a head and a head and a head and a head. Anywhere else it has changed at least 1 point. Here we had 3 heads in a row, 1, 2, 3, but our very last one was a tail, so now it's not the same coin. So on this side of our tree diagram, we have only heads. On the other extreme of our tree diagram, we have only tails. So these, anything else, all these other different combinations here were not the same coin. You can follow any of the lines down and you will not have all 4 coins exactly identical. So the probability of them not being the same is 1 minus the probability of it being all heads, 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 minus the probability of it being all, both tails. So this is how we can work with probabilities, that all the probabilities, as if we keep them as fractions or as we keep them as decimals, will add up to be 1. What do I mean by that? Well, let's look at when we tossed the coin the first time. There was a half chance that we would get a head and a half chance that we would get a tail. The second time when we tossed the coin, we would have got the chance of us getting head-tail was a half times a half, which was 1/4. The probability of us getting a tail times a head was exactly the same, a half times a half, which was also 1/4. And the probability of tail head, 1/4, and the probability of head head, 1/4. If we were to add all of these probabilities together, 1/4 plus 1/4 plus 1/4 plus 1/4, then we would get that the probability of all of these 4 different, of course, is going to be 1. The probability of a half plus a half is also 1. So all the probabilities on any particular row always add up to be 1. Let's have a look at the probabilities on this row then. The probability of us getting head, 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 the third time we toss the coin, well, it would be a half from the first time we tossed the coin, multiplied by a half, and the second time we could toss the coin, and a third head would give us a half again. A half times a half times a half is 1/8. So the probability of us getting head, head, head is a half times a half times a half, which equals 1/8. Well, the probability of us getting head, head, tail must also be 1/8. A half for the first head, a half multiplied by a half for the second, multiplied by. So all of the probabilities here are 1/8. 1/8, 1/8, 1/8, and 1/8. How many 8s do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. The probability of us getting all of the ones on these rows are an eighth 8 times, which of course also equals 1. What about the probability of us getting 4 heads in a row then? Well, it would have to get 4 heads in a row, we'd have to get first a head, then another head, and then another head, and then another head. So notice the and here. So the probability of us getting 4 heads in a row would be a half times a half times a half times a half. A head and another head and another head and another head. And whenever we say and, we multiply. Look at all the top numbers and multiply them together. 1 times 1 times 1 times 1 is 1. Look at all the bottom numbers, cover the top numbers with your finger and multiply 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So the probability of us getting all of the numbers as being heads is 1/16. At the other extreme, exactly identical for tails, a half times a half times a half times a half. So the probability of us getting all tails is 1/16. The probability of us then getting all tails or all heads, we could either be on this side of the tree diagram at one extreme or on this side of the tree diagram at the other extreme. So the probability of us getting all heads or all tails is 1/16 plus 1/16, giving us 2/16. So the probability of all heads or all tails is 1/16 plus 1/16, which is 2/16. That must mean that the probability of us not getting all heads or all tails must be 14/16, because all of the probabilities on the bottom row have to add up to be 1. And we have already used 2/16 or 1/8 here for all heads or all tails. So do we have 14 different numbers here in our tree diagram? Well, let's have a quick look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, and each of these probabilities down here will be 1/16. So how many 16ths do we have to add together that wouldn't have been either head, 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 or tail, 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 tail? It would have been 14/16. So the probability of not head, 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 or tail, 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 must be 1 minus 2/16, which is the same as 1 minus 1/8. So the probability of it not being head, 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 or tail, 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 is the same as 1 minus 2/16. Let's change 1 into 16/16 minus 2/16 equals 14/16, which is the same as 7/8, which is what we would expect. If the probability of us getting all heads or all tails is 1/8, then the probability of us getting not all heads or all tails would be 7/8. And that's how statistics and tree diagrams work.